Assalamualaikum warahmatullahi wabarakatuh. My name is Amri, Nadzman bin MAHUSIN. Our group will be presenting about wood as a sustainable material. For my article, the title is Laminated Veneer Lumber. For the introduction, the article is about the experimental result of the bending mechanical behavior, which is static and dynamic modeling, and maximum stress of LVL. For the information, wood widely used as building material, which is as renewable and biological, has environmental benefit in all phases when compared to other materials. Wood also has limits in comparison to other materials, such as its durability, fire resistance, and lack of homogeneity. However, there is an increasing social interest in building with a lower environmental effect. For the methodology, this is the example, the methodology in this article. This is the image of manufacturing process of reinforced LVL poplar panels. And here is the example of the result. For the discussion, first the Douglas LVL. The result is summarize the average values of the main mechanical properties of LVL Douglas field. It is obvious that two types of reinforcement act differently, and increase in the maximum stress of 16.4% was achieved for this type of reinforcement. For the popular LVL, the figure shows some examples for each failure pattern. Furthermore, all the beams with FRP test in flatwise position had shear failure. The reason lies in the fact that the flexural strength contribution of the FRP exceeds the shear strength of the popular veneer itself. As the result, the shear resistance becomes a key aspect for both design and proper application of the reinforcement. The table above summarizes the result obtained for the beams of Group 2, comparing the same type of reinforcement for different qualities of the panel. The importance of considering veneer quality as a key parameter to evaluate the mechanical result is clearly demonstrated. In conclusion, directional carbon has been shown to provide a significant improvement. The influence of the panel veneer quality was also clearly demonstrated. The weakest wood material improved the most in mechanical qualities when reinforced, allowing for stiff second quality popular LVL or strong second quality Douglas field LVL. The quality of the panel has been proven compared to the same type of reinforcement for Q1 and Q2. Reinforced Q2 popular LVL exhibited better mechanical properties than non-reinforced Q1 LVL. And lastly, when examining several types of reinforcement for low quality panels, as expected, reinforced beam produce the highest value, with equal result for carbon bidirectional and basalt and indirectional reinforcement.
Assalamualaikum warahmatullahi wabarakatuh. My name is RAFID bin ABDUL. Okay, today I will present about the structure behavior of the glue laminated timber beam, which is glue lamp pre-stressed by the compressor wood. For the introduction, this article shows an experiment about the glue lamp beam that's strengthened by inserting the compressor wood block into the pre-cut rectangular hole, which 1/3 of the beam depth from the top of the beam. This practice to make use of moisture defense swelling nature of the compressor wood was conditioned with the moisture content significantly lower the MJ1. Okay, for the objective to find out pre-camber will produce the bit span of the beam reinforced due to the expansion of compression wood blocks on the top of the part of the beam. The method used in this article, which is the pre-stressing process and measurement for the short glue lamp and long glue lamp, and then destructive flexible test for short and glue lamp. Okay, the experiment works is first is pre-stressing process and measurement. Diagram show the full size glue lamp beam pre-stressed by the 3 compressor wood block and 5 compressor wood block with lamina. Okay, next is destructive flexural test, which is the diagram about the deflection measurement to set up. Result and discussion for the free chamber deflection and pre-stressing state. Diagram 4 show the strain gauge location through the long beam depth. Okay, figure 5 show about the setup of measurement the pre-chamber deflection of the long beam, and figure 6 show about the setup of the 4-point bending test for the short beam, and figure 7 show the setup of the 4-point bending test for the long beam. And figure 8 show the graph pre-chamber deflection of the midspan of the short beam reinforced by the various compression wood block, and figure 9 show the graph the measure extreme fiber tear of the midspan of the short blue lamp beam pre-test at the top and the bottom. Okay, for the destructive fracture test, figure 10 show the graph measure the extreme fiber strain at the midspan for the long blue lamp beam pre-test and the top at the top and the bottom. Okay, and figure 11 show the graph the load deflection relationship obtained from the destructive test after the pre-stressing. A is the short blue lamp beam and the B the long blue lamp beam. Okay, the table 3 shows the summary of the bending texture of the start short beam, and the table 4 summary of bending test for the long beam. As you can see at the figure 12, they show the typical failure modes obtained from the destructive test after the pre-testing. The short blue lamp beam, it will be cracked, and for the long blue lamp beam, it will be delamination. And the figure 13 show the comparison of the pre-chamber and the peak load at the all beam. Therefore, all beam reinforced with different compressed wood or beam volume ratio. A is the short blue lamp and the B for the long blue lamp. In the conclusion, the use of compression woods made of low grade wood through the designification of the reinforcing material has been proved to be effective, as only a small amount of compressed wood is required and no bonding between the compressed wood and the beam is necessary. The technique developed economical and environmental friendly. This issue show that the controlled measure depending on the swelling compression wood is crucial to pre-stress glue lamp beam and to produce the pre-chamber as well as the initial stress to the cancel out working counterparty partially. Before the destruction bending test, this indicated tests are the significantly enhancement the bending capacity and the initial stiffness. For the short one, beam refers to the 3 and 45 mm thick compression wood block corresponding to the reinforcement volume only 1.2% and 1.8% of the total beam volume. There are increase of 90% and 22% in bending stiffness and 40% and 90% in load carrying capacity respectively.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali ALIAS, and I will present an article about characterizing engineering performance of bamboo wood composite cross-laminated timber made from bamboo, mat curtain panel, and hemfield lumber. The objective of this article is made to provide a guidance for future design and optimization of bamboo wood CCLT. The result presented in this article is to investigate their failure mode, maximum bending moments, bending stiffness, modulus of elasticity, MOE, bending strength, interlaminar shear strength, and specific bending and shear performance. Methodology that has been used in this article is bending performance, shear performance, and specific bending and shear performance. So this is the result that have been achieved in this article. The first one is the table of mechanical performance of hemfield lumber and BMCP. Number 2 is the layer structure of BMCP. Number 3 is the table of specific information for each type panel. Number 4, density of the bending shear specimen. Number 5, typical load displacement curve. Number 6, bending, and number 6, failure mode of the flatwise bending and flatwise shear test. Number 7, failure modes of the flatwise bending test. Number 8, failure modes of the flatwise shear test. Number 9, test result of the flatwise bending and shear test. Number 10, experimental values versus theoretical values of bending MOE. And lastly, number 11, correlation between MOE and layer thickness. And so, this is the discussion of the article. And this is the conclusion of the article. So as the recommendation, I hope that this type of testing will continue for the new type of material that will exist in the future. Furthermore, I also hope that it can be exposed more even to small companies for the good of our country, so that we can compete with other advanced countries.
So how the study is going to contribute to development of future sustainable product? So the study can contribute to the development of future sustainable product by giving the information about what sustainable product can do. The sustainable product can be compared to the usual product, and it is proof that the sustainable product are as good as the usual product by using the sustainable product. By using this sustainable product, it can save the environment and reduce the costs of construction, such as logging and buying the usual product. For the conclusion, based on the article that have been selected, we conclude that we choose CLT, cross-laminated timber, is the best product among 3 articles that have been researched. It is common and most familiar form of mass timber, the one that has opened up the most new architectural possibilities is cross-laminated timber. CLT structures successfully store huge amount of carbon and have been demonstrated to produce fewer emissions than other materials of construction. So it is recommended that the common process level standard be established, since this would expand the sectors of use for timber engineering and boost CLT in competition with solid mineral-based construction material. That's all from us. Thank you.